Today we're going to look at a new power bank from Bluetti. This is the AC180. It's 1800 watts. It uses lithium iron phosphate batteries, pure sine wave. Charge up in a little under an hour and a half, so they claim. We're going to check it out. Has all the other bells and whistles, USB-C, USB-A, DC output, solar charging, AC charging, and it can operate as a UPS. This looks to be a really nice built unit. I've been using my EV3A for over 2 years as a UPS, and it's been flawless. This big box arrived from Bluetti. You know what this is going to be, right? This is going to be a power station. Let's unbox it and see what we've got. There will be another box in here, for sure. And this thing has a fair bit of weight to it. It's not exactly a lightweight. A little more clearance to get this top box. This one's the AC180 portable power station. All right, let's get this bad boy open and see what we've got. It says keep the box. So inside the box we have obviously the accessories. We'll get to that in a minute. And the unit. It's got some nice hand grips to help us lift it out of the box. And there it is. The AC180, it's 1800 watts, 1152 watt hours. Features a DC or solar input, 12 to 60 volts DC at up to 10 amps. That's for charging it up. Has a DC output, 10 amp output. Features a USB-C 100 watt, 2 USB-A 5 volt 3 amp, and another 2 USB-A 5 volt 3 amp. So 4 5 volt. This must be on 2 circuits. I think they're probably shared. So you can plug 3 amps in here and 3 amps in there. But total is 3 amps for the two of them. And a 100 watt USB output. 4 AC outlets, 1800 watts. So you can plug your 20 amp appliances in. It's got both the standard 15 and 20 amp outlets. Also features wireless charging, 15 watts of output. The unit itself won't be charged. Pretty much guarantee it won't be fully charged. There might have some charge in it. It should have a charge in it. But we're going to charge it up, but we'll turn it on. We'll see what it's at. Right now it's at 54%. So we're going to plug it in and we're going to let it charge up. And then we're going to put it under a load test and run some big stuff like electric heaters and see how long it runs. On the left side we have a cooling fan. On the back side we have nothing. On the right side, this is where you would plug it in to charge. You've got a dedicated ground terminal, so you can ground it separately, a 20 amp circuit protector, and an AC input. Let's take a look at the back. It might have some specifications on the back, which it does. So let's take a close-up look at the specs. The model's AC180. As an input, 120 volts, 15 amps maximum. The DC and photovoltaic, which is your solar panel input, 12 to 60 volts, 10 amps, 500 watts maximum. So you can charge it from a 500 watt solar panel. Discharging temperatures minus 20 Celsius to 40 Celsius and minus 4 to 104 Fahrenheit. Charging temperatures 0 to 40 degrees Celsius or 32 to 104 Fahrenheit. Working humidity is 10 to 90%. Battery capacity 1152 watt hours. It's a 32 volt battery, 36 amp hour battery. Here's your output, 1800 watts maximum. Right, 1800 VA, 120 volts, 50 or 60 hertz switchable. And here's your output USB. Right, it's got a total of 2, USB-C can charge from 5 to 20 volts, 3 amps, and 20 volts at 5 amps. Wireless charging up to 15 watts. Cigarette lighter port is 10 amps. AC and DC output to 1800 watts total. The accessory pack contains your power cable. This is for charging from solar panels. It comes with a solar charging cable. It comes with a car charging cable to charge it from 12 to 24 volts in a car, so you can charge it in a big rig, for example, with a 24 volt system. And it comes with a beefy power cable, and this is a 15 amp power cable, a lot heavier than the ones you would find for your computer, which are typically a 7 amp cable. So you're going to have to use this heavy duty cable to charge it. I'm going to plug it into a dedicated outlet, the one I normally plug my electric heater into, and we're going to charge it up. And then once it's fully charged, we're going to run a discharge on it. I'll plug my heaters into it, draw as much power as I can, and see what happens. See how long it'll run and whether we can trip it. But we're going to load this sucker down and take as much power as we can from here. I'm going to fully charge it, and then we're going to load it up, and we're going to time it and see how long it runs under maximum load, and then let the unit cool down, and then charge it again, and we'll time it and see how long it takes to fully charge the battery. So we're not going to time it this time because it has a 50% charge. I'm just going to plug it in, and it boots up. It's at 54%. It will tell me how much I'm sure it's going to charge with. Does this unit operate as a UPS? I guess we can find that out. I know my other Bluetti operates as a full UPS, running on the inverter full time. To turn on the AC power, we would just hit the AC button. And before I even get this thing charged, we're charging at 290 watts now. I'm just going to plug in my heat gun just for the hell of it and watch what happens. Does the input go up? It should go up in value, which it does. I'm now drawing 936 watts from the output. My input is 1203 watts. I want to see when I unplug the AC power, does it continue to run or does it switch over? So let's just see what happens when I do this. So it's now on grid. When I unplug it, I heard a relay click. And now it switched back. We'll look at the specs and just see whether this one runs as a full. It's either going to run, it'll obviously operate as a UPS, as I just did. I had my heat gun plugged in, and it switched over. What I don't know, and I'll read the instruction on it, says it's going to take 2.5 hours to charge. Right now it's charging at 289 watts, but I have a feeling that I can probably put this into turbo mode. Let me just look up and see how I can set the turbo mode for charge. So the UPS function, it is a standby type supply because it has a switching time of less than equal to or less than 20 milliseconds. So it's going to switch extremely quick, which is fast enough for pretty much every computer system out there. It's going to switch within a cycle. Some systems like my EB3 run the inverter full time, so there is no handoff. It's instantaneous because there's no switch over. But this one does switch, as you can see. And it says, test this function before use to avoid the risk of data loss. So in other words, they won't be liable if your computer does shut down with it, because this is not, it does have a standby power supply function, but it's not being marketed as a full UPS, such as the EB3, which is a full UPS. And that is why I use the Bluetti EB3 on my computer system, because it is a full UPS and the inverter is running full time. It also features what they call a grid enhancement mode, which you can turn on with the Bluetti app. And it says this ensures that the AC180 has a stable and continuous AC input, and it allows it to adapt to voltage fluctuations and away from distortion. But if it's on and you're using it as a UPS, it takes longer to switch over and may be unable to provide instant emergency power to connected devices. So normally it's off on that, but it does happen. So I want to explain what that feature is. To enter the turbo or silent charging mode. You have to use the app to do that. It defaults to standard charging, which is going to take 2.2 hours. I want to turbocharge this thing, so I want to turbocharge. There we go. There's a new coin of the term turbocharging when it doesn't apply to cars. I'm going to turn the turbo mode on, and we'll see how fast this charges. I just want to get this thing charged up so that I can do my load test. I don't want to wait a couple of hours. So I do have the Bluetti app, I believe, on my phone still from before. I haven't used it in a long time. I wonder if it will support this model. So I guess I'll have to find it and see. So I'm going to connect this in Bluetooth mode. I'm not creating an account or anything. I'm in offline mode. I'm going to say click the available device. There it is there. I think that's it. AC180. Because I see both of my devices here. And it says tap the battery icon to view details. So let's just kick this thing up. Got it. Okay, grid. If we can see the display here. I can turn the power on and off here, but I'm going to go to this one. And I should be able to, can I set my power up? It's telling me I'm drawing 2.3 amps now. Where is my charge? Do I tap there? Okay, charge. Got to figure this out. One of these should let me switch it up here. Battery information. Oh, okay, that's switching the power. Maybe it's under settings. Under settings. Charging mode, here we go. So I can turn on and off the eco, which I can turn the auto sleep on or off, so it will never turn off. But I go into charging mode. Here we have standard, silent, or turbo. Click. Here we go to turbo. And we should see this thing start to ramp up the power here momentarily. If I turn on the DC power, I can plug anything into the DC port or USB or set my phone on top, and it will start charging automatically. Is it fast charging? Let's see if it's fast charging. It should be. It is fast charging. I don't know if you can see that on the screen, but it does say it's fast charging. And here's my output, my wattage to my phone. So I think this phone has a maximum charge of 9. This has an output of 15, but my phone itself only supports, I think it's 9. It's an old phone. I expect the charging watts to increase. I think probably the batteries have to warm up a bit because it's been sitting out here in the shop for about a week and it's kind of cold, so we're just going to let the batteries warm up. It's in turbo mode, so it should start to charge quicker once the batteries start to stabilize a bit. Alright, we're charged to 99%. I'm going to unplug the AC power and we'll plug in a couple of loads. This is my electric heater. Gotta move that a bit just so that the cord is long enough to reach in or reach to it. There we go. I'm gonna turn on the AC. We'll also plug in good old Mr. Heat Gun. And we're going to turn the electric heater on to full. So it's on now. When it fires up, it will start to draw power. There it goes. So that's going to draw. Oh look, we're drawing full power. I don't even have to put anything else on. I didn't have to put anything else on. This is going to draw the full 1800 watts, this heater. That's close enough to full power. And I'm going to start the stopwatch here. And we're going to time this and see how long it takes to discharge. Running a full electric heater at full power. So it's going to settle in now that the heating element is warmed up. It's going to settle in about 1600 watts, which is I think what this thing's rated at. So this will do 1800. If I put my heat gun on there even on low, I'll likely overload it because this draws about another 700 watts on low. So I'm not putting this into the boost mode. In boost mode you can draw more power. But according to this, at full power, we should get about just over 30 minutes of runtime at full power. So I will kick this in just to see what happens. You can see the range is going to drop down, and then we went into an overload shutdown. So now we have to reboot. I guess I have to shut it off to do that and turn it back on. And we can turn the heater back on. So I just had to power it off and power it back on. And once my heater fires back up, we'll let this run and drain it down. I'll stop the stopwatch at the moment while we're rebooting. There we go, we're back on now. So I'm gonna let it run, we'll time it. So I'm counting the minute and a half it was running before. And we'll see how long it runs. I'd like to tear this down and take a look inside it, and then we'll charge her up and time the full charge. But right now, we're going to discharge us at 1600 watts. According to this, it should run for about half an hour. Doesn't seem like a lot, but again, we're drawing full power. Obviously, if you're using this to power something that's drawing less power than its maximum output, the run time is going to be a lot longer. But this is only 1152 watt hours. So in other words, if I was drawing 1152 watts, it would run for 60 minutes. But I'm drawing 1570 watts on average. So obviously the runtime is going to be less. And in this case, it's going to be about 30 minutes from now. So we'll check in as it discharges and see if it lives up to that power rating. I didn't mention in this other little plastic bag, which I didn't even open, it has the grounding screw. So that's packed separately. That screws into that ground screw on the right side if you wanted to use it for external earthing. Like for example, if you're putting this in a motorhome or something and you were going to keep it there and use it as a power source, you could ground it to the chassis. Okay, we've been going for about 24 minutes, or a little over 24 minutes now, down to 18% of battery life, still drawing 1579 watts. We're down at 7% now. I'm going to let the camera run now until it shuts down so we can get an accurate run time. I didn't start at 100%. Remember, I started at 99%. I don't know what percentage it shuts down at. It might shut down when it gets down below 5%. We don't know. But it did say 0.6 hours when I started, so that should be between 30 and 35 minutes, I would think, of runtime at full power. Which is pretty good, because this heater does draw a lot of power. It's got the workshop nice and warm now in that half an hour it's been running. This heater is actually quite efficient. I'm running the tower heater, this big bad boy here. That's what I'm running with it. Down to 1%, so it should be shutting down any time now. What I'm going to do is, as soon as it's discharged, I'm going to plug it in and we're going to do a time charge before I tear it down. Okay, it just shut down, so 28 minutes and 30 seconds is what I got. Drawing full load. We're going to reset this now. I'll unplug my heater, and I'm going to plug it back into power and get the charging going. Now, according to the indicator, it's going to take about 3 hours to charge. The power should ramp up. It's starting to ramp up now to get to full charging power. Now it's down to 1.9 hours. We'll see what the actual charging power will be. I'm doing it now when the cells are warm. They won't be hot. Shouldn't be hot anyway because I didn't overload the unit, but I did run it close to maximum power. Looks like right now it's charging at 600 watts. We're in 57 minutes. There's 0.3 hours left to go. As you can see right now, we're charging at 1300 watts. We're at 75% in less than an hour. It took a few minutes to ramp up its power because I guess the batteries had to stabilize and get above a certain percentage, and then the input power went way up. Now charging at its maximum power, or close to it. I think it's 1400. It's maximum power. We're charging at 1300 right now. 1 hour and 12 minutes in, we're at 92%. 0.1 hours left, still charging at 1312 watts, or 1.3 kilowatts. Coming up on 1 hour 15 minutes now, the charge current has dropped down to 650 watts. The cells are at 97%. As it's getting closer to full charge, just like on all electric cars, etc., as the battery gets closer to full, the charging power goes down, and that's because as the cells get closer to their full charge, they tend to start to heat up a bit, so the chargers will ramp back, the battery management system will ramp back the charge current as we get to approach full power. We're at 98% now. We should be fully charged in the next couple of minutes, I would think. It still shows 0.1 hours, but we're getting close to that 100% charge. The power went back up to 1200 watts. You heard the fan increase in speed. Okay, the power has now gone down to 275 watts, but that last couple percent is what takes the longest. So I'm going to call it charged, and we'll end this charging now, and we'll tear this unit down and see what's inside it. Oh, wait a minute, it did go to 100. So there you go. Took an hour and 26, and it shut off. Now the power's gone to 0. So we did get 100. It says 99.9 hours. I can unplug the power and shut it off. Press and hold the button to shut everything off, and now we'll proceed with figuring out how to take this thing apart. I believe this one, the covers pry off. I don't see any screws in the bottom. The feet don't come off. Well, the feet come off, but there's nothing below them. I have a sneaking suspicion that the covers just pop off on this one, just like this. That's one cover. And then there'll probably be some screws to come out to remove the top and bottom. Same with this front cover. It's going to come off the same way. There'll be that one piece that sticks and breaks, right? There we go. Okay, that's got the front and the back covers off. I'm assuming once I get these out that the top will lift off, but you never know. Okay, does the top lift? Top should lift off, I think. Okay, these pop out. See that? I can see the top is loose. The handles come off. A couple more screws. And now will the top lift off? It should. There we go. All right, what do we got here? We got the inverter. Oh, there's a plug that came out on the front here as well. This plugs in, so this slides down and plugs into this other board. So once I remove this, we've just got our AC output. We can take this top piece off here. I think I can unplug that. Okay, that's the wireless charging. Here's our DC output, and that plugs in. There's a connector here that plugs into, and this is our AC output over here with our ground and our hot wire off the inverter, and our neutral line and neutral. Here's the inverter. One of these will be the DC to DC converter for the low voltage circuitry, and then this is going to be the AC inverter for the AC. As you can see, everything's glued down here. The big coils and so forth are all glued in place. The wires are all insulated and glued. Top quality build like I've seen on their other products. Pull the shield out of the way so we can see the inverter. So we've got a DC to DC converter here. This will be, one of these would be to step up the voltage from the batteries at high frequency to the higher voltage that is then going through the inverter. So some of these transistors would be, and diodes will be part of the inverter, and others are the DC to DC converter, and the others would be the AC power generation on the back here. Our AC power comes up over here. This is where the mains goes in, and the battery is actually over here. And I can't remove the inverter board on this one just because of the way it's built. The battery is in below here, and it's screwed right down to the inverter itself. But I can certainly measure the battery voltage. Maybe I can't. It's probably off. Okay, so the power is off to the battery. There's going to be a relay, I'm sure, under here in the charging circuit that shuts that off. But the only way to go down further into to see the battery would be to tear all this out, take the board out, take out all these screws, and lift the inverter out. And I don't feel like doing that. Unlike some of the other ones where the battery splits from the inverter, this one here, the battery is in the base, and then the inverter board is screwed down to the top of it. But we can see all of the transistors here. These ones are diodes. That's a diode there. Transistor, 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 and there's more transistors over here. This would be in the 60 hertz AC sine wave is being generated here. Those would be diodes, probably those ones, rectifying the DC that's coming off, or the AC that's coming off the DC to DC converter, because your battery voltage goes in here at what was it, 36 volts, goes through the transformer to step it up to probably about 170, somewhere in there, and then it goes into the AC sine wave generator, which is over on this side, involving this transformer and chokes and these transistors over there. Put the shield back on. That's actually not so much a shield, but to direct the airflow from the two fans. You got one fan drawing air in from the outside. This forms a chimney over the high power electronics to force the air through and then extracted on this side by the exhaust fan. So you got an induction fan on one side and an exhaust fan on the other. Basically this plugs in just like that. Yep, I've got power. It says I'm at 100%. I'm sure if I test the voltage now, we'll have power coming from the battery. So let's just put our meter in here so we can see what voltage we're getting off the battery. And we got 34.57 volts. And it is switched. So if I shut off the power, it shuts off the battery. Just like that. Power on, battery turns on. Turn on the AC power, and now the AC power inverter is on. We get some green lights on here too to show us that stuff is working. There's nothing on this side, but there's green lights on this side. There's a little green light down here. That's to show us that circuitry is working. And there's a couple more green lights on this little board here. But that's really all there is to see on this one. I'm going to power it down and put it back together, and we'll end this quick demo of this unit. There's our charger. Plug in the cable for the wireless charging and throw it back together. I would have liked to have taken this down further to show the cells in it, but it's charged. It's in this state. It's a hazardous unit. I don't really want to be poking around on a lithium power pack which is fully charged. It's just a little bit more on the hazardous side when it's in this state. I put it all back together. This is a more practical use. I've got a TV running on here now, and it's drawing 132 watts of power. It's a plasma set, so it draws a little more power than, say, an LED set, but this is to give you an idea. The estimated runtime is 7.6 hours. So someone using this for its intended purpose, camping, living in your van or whatever, and you've got solar panels, so you charge it up during the day. This will power your lights and all your small appliances, just charge your cell phone, power a TV, DVD player, etc. for several hours. 7.8 hours is what this will run for. And it, of course, can also be used as a UPS. It's a standby power supply, but it's still a UPS, so if I plug in power, it'll switch over to the grid, and we'll see our input power equal our output power. That way you can keep equipment running, and you've got lots of runtime. If you're powering up modems and gateways and so forth, and even computers, you could run them for many, many hours off of a battery like this in UPS mode, which is likely what this is going to find itself being used for here as a UPS. I use the smaller one on my computer as it sits. I may just put this one in place of it, just to give me that extra power for when the power goes down. Right now I've got enough power to run my computer for a couple of hours. This one would certainly go for a lot more than that. And I think the switchover is probably fast enough that nothing is noticed. TV didn't shut off or anything. Anyway, I'm going to put a link in the description, and we'll say thanks for watching. I'll catch you in the next one.